around. All right. So we know that between the kink bands, everything within that zone is going to be that dip. Okay, so between these two kink bands, everything's going to be 10 degrees. Between these two, everything's going to be 40. Here, it's going to be 0. Okay, so that cross with a circle around it means it's horizontal. If it's just a normal cross, then that means it's vertical. Okay, and then everything over here is going to be 85. All right, so that's how, and then everything over here will be 20. So that's how you break up your dip domains, is based on your kink bands. Okay, so we're just kind of simplifying. All right, so I know that if I'm in this boundary, I'm in this kink band, so I know that boundary is going to dip 40 degrees to the west. All right, and you're going to use a protractor, which obviously I don't have, but it's going to be 40 degrees to the west. And how do we know how to draw that 40-degree angle? What is it relative to? Okay, so horizontal. Okay, so now I know that this boundary over here is within this kink band, so it's going to be 20 degrees, but it's dipping the other way to the east. Okay, so I know that's going to be 20 degrees. Okay, something like that. All right, now that's just the general shape, but we have kink bands in there that we have to account for. Okay, and what do we know about kink bands and how they interact with the fold itself? What's the special relationship between the two? Okay, so there's a change in direction when the kink band is intersected, but there's something about the geometry of the kink band that's not perpendicular.
Bisect.
Okay, it bisects. So what does that mean?
You can extend both layers when they bisect.
Okay, so if I have this 40 degrees and this 20 degrees, and I have a kink band, it needs to bisect that angle. Okay? So if I know that angle, I can measure with my protractor, and I divide by 2, then what I'm going to do is I'll draw my kink band, and this angle and this angle need to be equal. Okay? Bisects it. So that's what helps you determine the geometry. So if you know the dip angle between your two beds, then you can determine where the kink is. Okay? So for this example, we have 2 kink bands. So we have one here, we have one here. Okay? And so, oh, there's a 10 degree in there too. All right, so here we go from 40 to 10, and at this kink band we go to 10 to 20. Okay? So I'm just going to draw this down here, but we go from 40, and then we go to 10. And they're both dipping the same way. So if I have a 40-degree angle here, and then a 10-degree angle here, what is that obtuse angle going to be? Okay, so whatever happens, let's say, I think it's like 150. Is it 130? Okay, so let's say it's 130. So divide 130 in half, and that's 65, right? I just made it up. We're going to measure this angle. We can measure that angle. Okay? And so if it's 130, we'll cut it in half, that's 65. So now, at this kink band, we know it's at the surface, and so we need to bisect that angle, so it's going to dip to the east. It's going to be 65 degrees this way. Okay? So let me erase this. Okay. So I don't know what I did. Okay. 45 degrees. And then over here, I'm going to have 40. So when that 40 hits that, that's when I'm going to start going 10 degrees. That way. Okay? So down here, I just drew it out to figure out the angle because I didn't know where it would be up here. So I just figured it out here and then made it up here. Okay? That's totally fine. Okay, so then we need to figure out this kink band and where it's going to go. And so for that one, okay, we're going 10 this way and then 20 that way. So that's the angle we need to figure out now. So we'll say that's 140. So then that kink band here is going to be 70 degrees, but this one's going to be dipping to the west. Okay, so it's going to be 70 degrees, pretty steep, maybe like that. And so when this one hits there, then I'm going to go 20 degrees that way. Okay, and then in the middle, so what rod unit do I have at the surface? There. A. Okay, so this is all A. And then what's underneath A? B. Okay, so if I have A in the middle and it's a fold, what kind of fold is that? Okay, it's a syncline. And how do we know it's a syncline? Okay, so youngest is in the core of the fold. So the shape is not enough. If it's a shape, but we don't have age information, then it's called a syn form. If we have age information, then it's a syncline. Okay? And so this is an example. If you have a fold like this, and A is in the middle, and B is on the outside, and A is younger, that's still a syncline, even though it has a positive shape. But it's called an aniformal syncline. Okay? So syncline, it just tells you about age. It doesn't tell you about the shape. Synform or aniform tell you the shape. Okay? Alright, so if we keep going here, if we look at the C boundary in the well, that should be 40 degrees. And if we know our kink band, then we know it's going to go 10. And then here's the other kink band, we know it's going to go 20. Okay? And a good way to check that is that if I know that this C is in the well, then that should be 40 degrees. And at the kink, it should go in here. And so the thickness should be really very similar. So if you screw up your kink bands, then your thickness is going to be off. Okay? The other thing that's an interesting check is that here we have C at the surface, yeah, and B here at the surface. So that contact there is between B and C. So if this is the right angle, then you should intersect that contact. Okay? And then that's going to continue up, and it goes flat. And there's another kink band here. So you would work out that kink band and see what its geometry was. And once you hit that, then it'll go flat. Here's another kink band. It's going to go the other way. And then, okay, so it's going to go flat. And then it's going to, once it hits here, it's going to go very steep down 85 degrees. Okay? So the real key here is using your kink band geometry to figure out